Alright guys, back at it again today. So today I'm just going to be drafting basically this subassembly. It's a motor for driving the blades under this deck, mounted to a flange, and it also has a mount for this linear actuator for controlling the height of the deck. So I'll just go ahead and draw up one of these and then repeat it 2 other times for all 3 of these motor drives here. So yeah, let's just go ahead and get started on that. So we'll just start with the motor first. Start a new part. Okay, so I'm just gonna bring this drawing up on this other window and I'll just use that as a reference. Okay. Basically I'll just start with that profile. So looks to be about 4 inches in diameter. And then it's got some additional profiles on it. Line. Just bring that in a little bit and shrink it down. So it looks like it's some sort of trapezoidal shape like that. Just do it like that. Looks to be a little narrower. Maybe a little bit wider. Okay, so that looks about what's on there. And it looks to be on each of the 4 sides, so we'll just repeat this pattern. Let's just go ahead and fully define it before we do that though. Round it. Okay, fully defined. Make it a circular sketch pattern. We want these as well. And there we go. Just trim these out so we have a solid shape. Okay. And go ahead and extrude it. Looks to be about the same height as it is wide, so we'll just go 4 inches. So basically that's the body of it. Seems like these edges aren't left sharp, they're got a fillet built into them. Okay, yeah, let's just leave it at 0.1. Okay. It looks about what the drawing, what this image looks like, so I'll just leave it at that. So we also have a flange on here as well. Go ahead and sketch on that. Just a rectangular shaped flange. We just want it centered, so we'll find the center line there, make that vertical, and then find the center line here, make it horizontal, and both for construction. So these will both be equal. and set that to 3 inches. So a 6x6 flange. Looks like it's a little bit smaller than that, maybe 5x5 flange. Looks a little better. I could go with that. All that good. Extrude it. That looks like maybe 1/4 inch or 3/8 of an inch thick. Just say 3/8. See what it looks like. Yeah, it looks pretty close to the drawing. Likewise, edges aren't left sharp, so we'll put a fillet on them. Looks like a little bit bigger than what was on the motor, so go 1/4 inch. There we go. There's some holes in these to mount it to this flange plate, so let's just go ahead and add those in this drawing. Set these two equal to each other, make them for construction. Let's just say these are mounted with my favorite thing, 3/8 bolts, and we'll set this to some dimension, maybe 1/2 inch. Okay. So just as a reference, we can see what a bolt looks like on there. So I know a 1/4 inch nut typically uses a 7/16 wrench, so a 3/8 nut would probably use a 1/2 inch wrench, if not 9/16. So let's just say 9/16, not 100% on that, so it's probably about what the size of the nut's going to be. So it looks like it's located a little bit closer to this, so we can make a small modification of that to bring it in. So a little close, let's just use 2 3/8. Okay, so that looks good to me. Let's just make all these lines just construction entities so they don't show up in the final drawing. So we can just mirror this about this, and then mirror these two about this. Okay, there we go. So that's starting to look like a motor housing for driving these blades. Before I go any further, this particular part of the motor is black. So let's go ahead and color it. And let's make it this shade. Let's see if we can add this element in there too. Yeah, there we go. Okay, so let's go ahead and save it. Let's call it blade motor. Okay, so there is the top of this motor that it has the harness for powering it. So easiest thing to do, just convert these entities. Go and extrude it. 1/4 inch. So this one's going to be silver. So it looks like it's just trying to shade that face. Let's just go back on it. Okay, let's try one more time. So what is this extrusion? Okay, I think I realized what I did, so we'll go back to this feature. Just unmerge it. There we go, two separate entities. Okay. And from there, let's do another sketch on here. Start by just grabbing all those entities from the last sketch. And then these two side ones aren't here anymore. Just this top and bottom one. So what we'll do is see if we can just extend this around, and then just trim these out of here. Okay. Extrude that. Appears to be maybe about an inch in thickness. Let's see what that looks like. Okay, so that's kind of looking like what I'm looking at. There are a couple holes for bolts here, with bolts going through there, but I think I'll just opt to leave those out. There's a harness here, so let's just see if we can't add in a connector for a harness. About like that. Let's just call it 7/8 thick. I'm sorry, 7/8 diameter. If I'm not mistaken, this is some form of amphenol connector, and so it has basically a wall around it and then a bunch of little pins on the inside. I won't draft the pins, just basically this cylindrical shape, just to give it the appearance of a connector. Okay, maybe 3/4 inch. How about 5/8? Looks about right. Okay, so just like I said, just give the appearance of a harness connector right there. It's a vastly simplified shape for that, but that's fine, just so we know it's there and we can kind of tell the orientation of this motor. Okay, so basically that's the motor. So what we'll do is create an assembly using this motor, and then within the context of the assembly, we'll draw that flange plate that it's mounted to. Make assembly. Just drop it anywhere. Make a new part. And we'll use this as a reference. Okay, so I mentioned the connector, the harness connector, to kind of tell us the orientation of this motor, so we know it's kind of facing up or back towards basically the chassis of the mower. So let's just go ahead and get a rough shape of the flange. Appears to me that this motor is centered in this flange. So we'll go ahead and add some lines in there to create that. And vertical. Okay, there we go. We're centered now. I'm just going to kind of eyeball this as well. So it looks like the width of this is not quite another motor length, so maybe about like that. And then this dimension, this width, just a little bit, just enough to put some bolts in. So it looks probably pretty close to what it needs to be. Let's just make it a round number. 7 inches, probably okay. And we can go ahead and just throw some holes in there for bolts. Make these two equal. Whoops. Make them for construction. 5/8 from the edge. 3/8 holes, why not? Okay, so it looks like it's going to only get a little bit close to that. Let's just draw it up and see what it kind of looks like. So basically we know these are all equally spaced. And we can set this line equal to this one. Go. So actually, let me just double check that. Okay, so let's go ahead and set all 3 of these lines equal to each other, and it fully defines without having to establish any dimensions. So that's looks pretty close to equidistance between this edge and this edge, so we'll leave it at that. Let's just mirror these about this center line. And go ahead and extrude this plate. Plate appears to be let's see what 1/4 inch looks like. Looks pretty reasonable. Okay, so that's the plate. So these edges don't look like they've been left sharp, so we'll go ahead and round them off a little bit. Just try 1/8 inch radius, see what that looks like. There we go, that looks pretty good. Okay, last thing is there's a mounting point on here for the linear actuator that controls the height of the deck. So it appears to be like it's a piece of square tubing that's mounted on there. And then it mounts to the linear actuator via some pin. So let's just go ahead and start with just drawing this piece of square. Just make all those equal. Let's just put it into the middle of this plate. It's just doesn't look like 1 inch, maybe 1.5 inch square tubing. That looks reasonable. Okay, and so that's the only other thing. Just make that midway between the edge of this motor and the edge of this plate. Make equal. Right, just go and extrude that, 1.5 inches. So we're left with a block here. Just make this hollow. Convert entities and then offset entities. Change that direction. So about 100 thousandths thick wall. That looks good to me. Go ahead and cut it. Okay, that tells me there's a mistake in there. So these, we're not actually going to use them for the extrusion, so we'll just turn them into construction elements. Extrude cut. Grab one of those, and there we go. And up to surface, and we'll just pick the surface we want. There we go. Okay. So that's kind of looks like what's on there. Just for the fun of it, it appears that shape is kind of like that, I would imagine, and so you can get to the heads of the nuts to tighten them down. So we can just go ahead and draw that pretty simply like that and just cut through it. Okay, so kind of looking like what I'm looking at there. So now basically the mounting points for the linear actuator. Just draw a center line. Go and just center all this. Make that 3/16 thick. Just say 1 inch. So how about 3/4 inch? So basically the last element we need to define is what's the distance here. So I'm just going to say the base of that mount is 5/8 inch thick, so 5/16 distance between the two. Let's go ahead and mirror everything here. And extrude it out. Maybe about 1 inch. I wonder why that looked kind of strange. There we go. Quarter-inch hole. Just assume there's a 1/4 inch bolt that goes through that to mount that actuator. Let's just establish some distance from the edge, 1/4 inch. Cut that out, and so we have that. Thinking these edges are probably rounded off. Okay, so that looks about like what I'm looking at there in the picture. Only thing is this part's painted yellow, so we'll just go ahead and make it yellow. Okay, so that looks about like what I'm looking at. So let's just save this assembly. Let's just say let's just save it with context. Okay. Let's go to this. So, I think the best way to mate that part onto here will be to put some references on this, on the deck of the mower. So let's open it up and basically just put some holes in it where we think that blade is going to come out. This one will certainly be in the center. We want to make these two equal for construction. Basically, it doesn't have to be too large. It's just I'm just imagining it's big enough to allow a shaft to go through to drive that mower blade. Okay, start by getting this one fully defined. It appears to be midway between this surface and this distribution box. So let's see if I can grab a center line off of here. Yeah. Just get rid of this. And we'll just make a line from here to here. Make these two elements equal. And for construction. Okay. So that's that. So this one, let's kind of estimate how far it is from the edge. Maybe 8 inches. It looks okay. So the center of this should be in the center of this mount, because of course this linear actuator runs from this flange to this mount. So go ahead and just delete that out. Same thing here. Just find the center line, vertical, and make a construction entity. And let's see what it looks like centered between the two. Yeah, looks about right. So I'll go with that. Let's just mirror this about this. And so there we have 3 holes as a reference to mount these flanges on there. Cut through those, and we're left with those holes. Looks good. Save it. Close this. If we need it, we'll open it up later. Okay, so our holes showed up. Let's go ahead and insert this flange assembly. So we can grab a circular element here and here, make them concentric. Okay. And bring this up. Make this surface onto here. And finally, we're going to want these two surfaces parallel. And let's take a look at it. Okay. The image I'm looking at, this motor looks like it's a little bit tall relative to what's actually on the mower. So we can easily change that. So we extruded 4 inches. Let's see what 3 inches looks like. And we want to leave that the same. Just make this 3/4 inch. So hopefully it doesn't throw this off too much. I'll just save it and see what it looks like. Okay. Yeah, so that looks a little bit better, at least what I'm looking at. Okay, so let's just add in a couple more of these. We can just use that surface as a reference. Same. And then these two. And then likewise these two surfaces parallel so that it won't spin if I end up moving something on this assembly. There we go. Okay, so it's looking like this drawing that I'm looking at right now so far. The only thing is this middle one does not have this mount on it, so what we can do is make a derived configuration of it that doesn't have that mount. Okay, center flange. Okay. Just go ahead and sketch on this surface. Just an arbitrary rectangle. Okay, and this direction. Okay, and it's gone. Go ahead and save that. So this is where I'll have to kind of center flange. Okay, so it changed all of them. Okay. So let's open this assembly. So basically, we'll just have to save 2 different parts. There might be a better way to do this, but I'll just do it this way just to save time. So this is the option we want. Assembly, center. Okay, so we don't need this open anymore. Okay, we can close this as well. We'll open it if we need it. Let's open this one. Okay, so this is the center one. We'll just change the configuration on that one. Save it. We'll just leave it open. Let's open this one. It's asking me to update any changes. So let's just delete this one out of here. Delete the subassembly, and then insert components, and just the center one. Okay, so let's go ahead and made everything back up. And there you have it. So this one doesn't have that mounting point like these left and right ones do. Okay, 36 minutes. So let's see what else. So I guess next step would be to add those linear actuators in there. I can also make the drawing for these wheels too. So let's make those the drawing for the wheels real quick. That should only take a minute. Like all the other wheels on this, we'll just draw a profile and then revolve it around that profile. So let's go ahead and establish a center line. Looks like it's pretty much in line with that. Up, and then there's some curved surface here for the wheel. I believe the back side of the wheel is going to look a little bit like this. Just guessing. Doesn't really matter too much. Just try an ellipse, I believe. Before we do that, let's just make a construction entity. Actually, okay, so basically we'll start with the center line, goes to these points, and then we can kind of establish how round this wheel is. Maybe about like that. And then we'll just trim off this side. And that looks like what we're kind of looking for. Let's go ahead and establish basically a wheel diameter. I'd say that wheel is probably about like that, maybe about 4 inches in diameter. As far as width goes, maybe 2-3 inches. Let's see what 3 looks like. I was thinking maybe there's just very little of a shoulder on there. And this is recessed. Looks to be a good portion of it's recessed. Five. So this hole, let's just say 1/2 inch diameter. these two lines go linear. Okay, the only thing that's not dimensioned in this drawing is this. We can put a dimension in here, and that way if we want to go back and change it, at least we can just change the numbers gradually until we get something that looks correct. Revolve this about this line. Okay, and so that looks pretty close to what I'm looking at. And this part is also black plastic probably. I believe this is called maybe an idler wheel. Okay, let's just throw one of these in here. Kind of reluctant to add, looks like 6 of these wheels on here. I'm a little reluctant to add all those in there. It's just going to take more computing power to have them in this assembly, so I'll just put one in, and then at the very end of this I'll put them all in. Okay, so of course this will be concentric with this, and then basically this will kind of contact that. So there's more to it than that. I'm sure there's some sort of bearing on it right there to keep it from rubbing this plastic, but for our intents and purposes that's probably fine like that. Okay, so that kind of looks like what I'm looking at on the drawing. So that's one of the idler wheels. So we'll leave it at that and just add the rest in, like I said, at the end of this project. Let's see, I'm trying to keep this around an hour. I got about 15-20 minutes left. So yeah, let me see if I can get this linear actuator drafted and put in here. So let's go ahead and start a new part. Okay. Let's just start with the base of this thing. Maybe about 2 inches wide. I'm just going to kind of have to eyeball this. Looks about like that. What's that sort of distance? Let's just round it to 3, so it's about 2 inches wide and 3 inches long, give or take. Okay, let's go ahead and extrude that. Maybe about 2 inches. Sketch on here. Okay, that's helpful. Basically, the part where the gears are and the I'm sorry, where the motor is concentric with this one, so that makes it a little bit easier. Instead of doing it like that, let's just make it just a little bit smaller than that, because that's what it looks like in this drawing. No, not quite that. Yeah, maybe a tenth of an inch smaller on diameter. Go and extrude that. Let's just say 6 inches, see what it looks like. Looks reasonable. And there's some sort of top on this, just add for detail's sake. Like this other thing, it just looks like it's a little bit smaller than that, so I'll do it that way. Extrude it, not 6 inches. Looks to be maybe half an inch. And then it almost appears to be a little bit of a cap. maybe a 1/16 in radius. Okay, so that's kind of what it's looking like. And now let's go ahead and draw the actual rod part of the cylinder. It almost appears to be one of those extrusions, aluminum extrusions. So maybe we'll draw it like that. This midpoint. Let's establish a diameter or a dimension, 1.25 inches. And appears to be centered about that, so just make these two equal and then turn them into construction entities, and that looks about right to me. And so this, like I said, looks like some sort of extrusion. Let's see if we can't make it look close to what it looks like in this drawing. Like that. See how that looks. Looks okay. Looks a little strange to me. It's hard to kind of see what that looks like, but I'll just make it as close as I can to that. See if there's some sort of relation here. No. Just for construction, and just make these collinear so that this line is perpendicular to this circle. Just go ahead and mirror this about this. This about this. Okay, so basically everything is symmetric. Actually, hold on, don't want to do that quite yet. About this. Alright, just trim everything out after that. So, something like that. See if we can't just establish dimension. Yeah, to define the sketch. Okay, last thing this is missing is, let's just make this for construction, just to keep those relations, and then this one is the one we'll trim out. Okay, let's see if we can't extrude that. Okay, so it's going to stick out past this a couple inches. What does 9 look like? Maybe a little bit more. Maybe 10 inches. So these two are, they look like they're much further or much closer together in the actual drawing. So let's just go ahead and start with this base geometry. Bring it down to 2 inches. Okay, so that looks a lot better. Okay, on top of here there's a flange, so let's just convert these, and then there's a couple holes for bolts. We can add those in there without a whole lot of heartache to do it. Just extend that out to there, set these two equal, and make them for construction without vertical. Okay, now those lines are fully defined. This is going to be quite a small hole. Just make it 1/8 of an inch. And so let's just make a couple lines so we can mirror these holes onto each one of these ends. Extrude it maybe 1/4 of an inch. That looks good. So this looks like it's a darker shade of gray. Before I just get rid of that merge result, so now it's clearly defined this flange to this rod end link. Just this extrusion, just make it a darker shade than the rest of it. That way we can tell. So looks kind of like what I'm looking at right now. Well, I saw a couple things on here. Let's just go ahead and add where it'll connect to that part on the deck. Let's say this is make it 3/4 of an inch. I forget what spacing I made for that. Just sketch on this surface. Um, 3/8 hole. We'll locate that maybe 1/2 an inch from the edge, or maybe 3/8 inch from the edge. Go ahead and cut it out. Okay. Put a chamfer on that. That looks good. Okay, and finally, I'll take it back. Basically, I want to make an assembly with this and just have the rod a separate entity of this assembly. That way, it can extend out and go back in whenever I move the deck and the total assembly. So just go ahead and save this as there are several linear actuators on this, so let's be a little more specific. Some of those other linear actuators look like they play a role in adjusting the height of this. So let's just say wheel adjustment. Linear actuator. Okay. Let's go ahead and create an assembly. Put this in here. Make a part. I use this as a reference. And so I'm going to assume it's a 1/2 inch rod diameter. Go ahead and extrude that out. It probably has a maximum extension of maybe about 6 inches. So let's go ahead and make a sketch on this plane. Just say a 1/4 inch hole in it. Make that for construction and locate it a 1/4 inch from the edge. Both sides, there we go. And then we'll just go ahead and add a little chamfer on this. We'll use the same. Okay, and so that's it. And so this mate's going to be in place, so we'll just remove that one. And so now we're floating, right? Go ahead and mate it, grab a rounded surface, and now these two are concentric, but it's free to rotate like that. Let's just go ahead and mate a couple of the planes. Okay, let's mate the plane of this part to probably the plane of this part. There we go. So basically, just make them parallel. So now we're free to go in and out. So I need to brush up on my SolidWorks. I know there's a way to create a stop in this, but I haven't used it in a while, so something to do with interference detection. So let's see if I can't figure this out. I don't want to spend too much time on it. I'll take it back. This just going into this solid body is just gonna throw an error right away. So we'll just leave it like that. I think that'll probably be okay like that. Okay. So this will be wheel point feature symbol. Okay, and let's go ahead and drop that into this. Alright, grab this round surface and make it concentric to this one. Okay, so it looks like it fits in there, so what we'll do is just an advanced, basically symmetric sort of mate. There, so now we're fixed there. Wow, so I must have really overshot this for it to be off that much. So looking at what I should go ahead and modify to get that to fit in there. Thinking maybe this whole linear actuator is just too big in general. I'll go ahead and just shrink it down a little bit. So yeah, let's just go ahead and shrink it down. Okay. Okay, so I made that a little bit smaller. Everything else was kind of driven on that. A little bit too big, maybe 1/4 inch. How about 1/8 inch? Okay, and then this one, let's fix this drawing. Let's see if we can shrink that down. Let's take a look at that, see how that looks. So this is floating out here. Let's go ahead and make it coincident with that. See if we can bring this down a little bit. 1/2 inch, and then this 5/8 possibly. A little too much. 3/4 possibly. 3/8. Let's take a look at that. Let's see what that looks like. Not too bad. They still look like they're a little bit far apart, so let's just fix that. Shrink that down a little bit. There, a little bit closer now. That looks like that sticks out a little bit too much now. Let's just go half of that distance, 3/4 inch. Looks a little better. Lastly, this. No, not that. Just change this diameter. Okay, looks a little bit better. Let's just go to the assembly. Go ahead and edit that component. Just change this diameter a little bit big. 3/8. Maybe that'll be a little bit better. That hole looks a little bit big. .1875, 3/16 of an inch. Now let's take a look at it. A little bit better. This is looking a little bit long now, though. So let's open this part. I could have edited it from there, but not a big deal. Let's make this 8 inches now. Just make this a little bit shorter as well. Okay, let's leave it at that. See what it looks like in the assembly. Okay, so a little better, but still. I must have vastly overestimated the size of this thing. Okay, let's just make it even shorter then. 8, how about 4 inches? And then this one, make it 2.5. Okay. Alright, so we have this part open. Let's so this is an assembly. Let's just get rid of it. And then reinsert it as the individual part. Make those two concentric, and I pretty much knew where it needed to go. Make this symmetric about that, and let's go ahead and insert that part. Let's get out of that. Try it again. Make it concentric about that. And concentric about that. So looks like it's a little bit small, but we can live with it. Alright, so moment of truth, will this work? Now, there we go. Okay, so that's not a bad result. You know, it works in tandem with that, so that's good to see. So let's just go ahead and add the other one in, and then we'll call it a day. Concentric, and then let's make an advanced mate. It's called width, but it literally just makes it symmetric between the two surfaces. There we go. Insert another one of these. concentric to that, and finally concentric to this. Okay, let's see if these work. Yeah, good deal. They work in tandem too. Okay, so getting a little more complicated now, but it's also looking a little better. Went ahead and watched a video on this thing, and apparently this these back wheels do pivot on this point, so possibly I'll go back and edit that so that they'll pivot like that. But yeah, so far so good, coming together. Got those motor assemblies on there for driving the blades, and also added the linear actuators controlling the deck height, and even put a idler wheel on here. So it's not looking too bad at this point. I think we also have some linear actuators that mount the deck to this chassis here. That's something that should get added in there as well. And there's also basically a bumper bar. I'm sure it's connected to possibly a limit switch in case, in the event this thing crashes into anything, it'll tell it to cut it off. So that's a pretty large element of this. But so far it's coming together. I think that adds quite a bit of detail to this and starting to really look like what I'm seeing online. So just wrap it up there, and we'll see you next time on this.